So thank you very much, and I will answer your question in a detailed way in this presentation. So my name is Gabor Jarvas, I'm from University of Pannonia. Thanks to my engineering background, usually I like to organize my presentation around 3 questions: what we did, why we did, and if I still have time, how we did it. But allow me today to be a bit more storytelling, because I guess it will help you help me to emphasize what we did so far and what we changed on the glycomics workflow. So at the beginning of my presentation, there will be some historical parts, how we continuously developed the GU concept, the capillary electrophoresis-based glycan structure identification, how we get to the so-called triple internet standard approach, and then how we drastically changed everything around this development process. And later on, of course, I will focus on the reference, which is the name of our new suite, what we developed so far. So, yeah, you know, all of you know pretty well what's the point of this GU-based approach from glycomics. Actually, if we have a CE-LIF setup, then we have 3 different ways to analyze or identify the structure. That's the direct way, when we have just few peaks in the trace, which allows us to identify with high confidence if we know at least what we are seeking for. But if we do not, if that's not the case, then we should go with the GU value approach, where we are mitigating the peaks, shifts, instrumentally, inter-day, inter-laboratory, interpersonal ways. So there are so many reasons when the peaks can shift. And if it is still not enough to confident peak identification, then we have the third options, the so-called exoglycosidase digestion, which help us to identify the certain peak of a question. But this exoglycosidase approach is very time-consuming, complex process, so it's not the one what we can use in the daily routine. And if we go further with the GU value approach, the GU value approach is a kind of calibration of the migration time with the ladder standards. It is following the basic approach developed by Kovács Ervin, who was the member of the Hungarian chromatography mafia, and used that approach to calibrate the GC columns. And the GU concept for C is actually the same. We are calibrating somehow the capillary, because again, there could be so many reasons to shifting the piece. And what we do, actually, we just simply correlate an analyte peak against the ladder sticks. And if we found which is the corresponding degree of polymerization of the element of the ladder, that gives the first part of the G value, and then it's a kind of ratio approach between the different sticks. Ah, great, thank you. Ah, okay. No, I am the Jedi. Okay, so. So that's the basis of the GU-based approach, and there are different ways. This is the formula how we are calculating in a traditional manner, and as it is very complex and usually manual, there are different approaches how to speed this up. There is a way where the polynomial is applied to describe the migration behavior. It is also good, but as you could see in the R-square, it's very accurate, but in some cases it's not applicable. So when I started to the Gutmann laboratory, we automated this GU calculation and developed the so-called GU up, which is again doing the comparison of the analytes against the ladder. And based on a very simple calculation, and based on the result, the GU values, we can do a database search, and then we can get the certain structure. In this way, we have to measure one ladder for each sample trace, and albeit that app used a lot and make it very practical, it was still a very, how to say, very slow process and very complicated day by day in the laboratory. So we further developed this traditional approach and result in the so-called triple internal approach. In this way, you should not run a separate ladder for each sample trace, because we realized that based on the well-detailed analysis of the migration behavior of the glycans, we were able to predict the a so-called virtual ladder which can be used for the calculation then in the traditional way. So based on just the migration times of 3 internal standards, DP2, DP3 and DP15, we were able to build up the virtual ladder, and then we compared this virtual ladder just to see, and if you see, the sticks are very close to each other. Actually, the accuracy is very, very high, and then again, in one run, we have these 3 internal standards, what we use to get the virtual ladder, and the virtual ladder can be used in the same way as in the conventional approach. This doubled the speed of the calculation. Why? Because you do not have to run a separate ladder to get accurate information on the CE-based structural elucidation. We have implemented this approach in an app as well. So it's very much more simple because it missed the ladder part. And yeah, so that took us more than 7 years. And then we realized that, not realized, at the beginning we had a kind of feeling that we lose some glycans, because of course it all was based on the APTS labeled glycans. And then we started to go more into the details and investigating what's going on during the purification of. You know pretty well that the APTS should be applied in a way much higher excess than necessary, and then the excess dye should be removed. And there are different ways to remove these. You can use solid phase extraction or magnetic bead-based technologies. But again, if you compare these two, the purified trace against the non-purified, it's so obvious that during the purification, there is a chance, a high risk to lose glycans. And it is not just for CE, it also could be valid for HPLC as well. So then we got to the decision point where we finished to further develop, to further, how to say, further do the evaluation of the traditional CE-based glycan structure identification, and we did a huge step and start to develop a new method where there is no need for excess dye removal. And then we got to the solution where we work at alkaline pH when the EUF is rather high. So we do not suspect that EUF, but we use it. In other words, it's not a bug, it's a feature for us. How we do use? We simply change the polarity, and in this case, the EUF is throwing out the separation media in the injection site, but the migration is dragging the glycans towards the detector. And this is what I try to plot in a schematic way. And that's the reason why, Edmund, for example, you have seen this unusual unusual appearance of the ladder. Here's it in a more detailed way. So in this, we called that approach CATRIS because caprylic acid used in the buffer system. And here's how this new approach looks like. So I would say, again, it's not a further evolution, further development of the traditional way. It's a brand new one, so I would call it as a revolutionary step of the glycan identification based on CE. Yeah, how it looks like. Oops, sorry. So the higher the DP is migrating earlier, and so forth, so forth. Here's another good demonstration of what is the effect of the sample cleanup. In this butterfly plot, you could see this is the non-purified trace, and this is the purified. And it's so obvious. We lose a sample, we lose glycans due to the sample cleanup. And keeping on this, how to say, to demonstrating what's going on during the sample cleanup, we further continue the investigation. And it's a very, how to say, very logic way for us to test what could be found in the waste during the sample cleanup. And surprising, you see, those are the peaks that you lose during the sample cleanup. That is why I call it a revolutionary step, because in this new approach, there is no way to lose those glycans. For example, it's also obvious. In the non-purified trace, you have these two small things, but in the purified, it's completely disappeared. And I do believe those glycans can hold very important clinical and biological informations. And I do believe, again, it's not just the case for the CE-based glycan structure analysis, but also for the HPLC approach. So if we have this purification-free approach, then we can get a way much more closer, how to say, closer profile to the reality. Because what we have measured so far, I do believe we always missed those peaks, what is demonstrated here, for example. Of course, this is just an example, but you know, we had the feeling that we lose so many glycans in the couple of last years. And as we have EUF used in this separation scheme, therefore the traditional GU value calculation approach could not be applied for this method, because we have to deal somehow with the measure of the EUF. And the EUF, of course, can change very easily because it's very sensitive to the temperature, sensitive to the condition of the capillary interval, because not just the analyte but also the compounds of the buffer could attach to the internal surface of the capillary, which resulted in the change of the measure of the EUF. Therefore, we have developed this new approach. First, we would like to find what is the certain value measure of the EUF in the certain measurement. So that's the first step. What we do, we have identified in each calculation cycle the so-called virtual EUF, which is a kind of marker. What is the measure of the EUF, and then we can calculate. In a similar manner, we can calculate the GU values in a similar manner as we did before, but again, in this case, we are taking into account the measure of the EUF. And if we carry out this very complex calculation, then we can demonstrate that the result, the traces are very, very close to each other. So there is no, apparently there is no shift between the result of the electropherograms. The calculation method itself is very, very complex. You could see the algorithms on the left, but we implemented everything in a simple software, in a simple calculation software or app, what we have dubbed right now as reference. And this reference is based on different publications. We also submitted it for patent protection, actually 2 patent applications. But the main features of this reference is that it's a cloud-based solution, so you should not install it on your computer. It's available where you have internet access. It has the audit trail, meaning that once you have done with one calculation, then the results cannot be changed. Of course, you can re-evaluate it in a different way, but the original could remain intact, so it's suitable for carrying out a diagnostic pipeline. For example, right now we are doing the alpha testing of the software, meaning that it's not published yet, but internally we carry out so many different measurements to see what is the application domain of the application, and which is very, very important. Who those doing for example, the CE peak integration in daily routine. That's the traditional approach for integrating the peaks is very complex and a very time-consuming process. Therefore, we decided that we would add an extra feature to this reference, which is the automated peak integration. And we made it, I mean, the software itself suitable to handle all of the traces coming from different vendors like Beckman, Agilent, Prince, whatever is it. And also it's suitable to simply process the XY data if you have just that one. And to show you how simple is it, I just make a slide. So log in, I guess it's 5 seconds should be okay if someone remember to the password. Then you have to select the files that you would like to proceed. This suite is allowing having one ladder and multiple sample files, so we can carry out a batch of a batch calculation for repeated samples, for example. Then we have to how to say, set up the proper look of the ladder. It is fully automated, so you just have to tune these buttons, and then it will found the good corresponding peaks for the ladder. Usually it takes around 30 seconds, and then you can go further with the sample. Here you can choose between which peaks are you interested in. You can choose all of them. You can just cherry pick a few of them what you are interested in, and then you are ready to go further. The next step is to set up the baseline for the integration. In a simple case like this, it's so obvious that you can use here, but if you have, for example, increase in the baseline, then it's very tricky to set up the baseline for the integration. This is why we decided to go not just to pick up one point of the baseline, but the range, and it will calculate the average, and that will be used to set up a proper baseline for the whole integration along the whole trace. So that's took another 50 seconds, and then within a minute you are ready to carry out the calculation. The calculation of the GU values of this very complex way, together with the peak integration, is usually carried out around 1 minute, meaning that 2 minutes together allow you to get a fully integrated, fully announced trace. And if you have an additional 5 seconds, then you will get the results in a table format that you can extract, and then you can use the data for further evaluation. So this is what we achieved so far, and a few thoughts about why the peak integration is carried out in our approach in an automated way. Kerry Zager, Tim Blank, and Herman Wartig published a paper about the importance of what should be the tunnel rules for a manual peak integration, showing or demonstrating for us, at least for me, that it's a very important question to do the peak integration in a repeatable, robust way. And also, there was a preliminary study. This team put together a kind of benchmark set of electropherograms and sent it over for experts, independent experts, and asked them, please do the data, do the peak integration based on your expertise, based on your routine as well. And if you could see the different experts integrated in a completely different way of exactly the same electropherogram, showing again that the automated peak integration is a demanding need nowadays in capillary electrophoresis-based glycan structure identification. And what we have decided how to go, we simply rely on the calculated GU values. So if you select one peak, to calculate the GU values for the certain peak, then the software will automatically integrate it. And that's all. In this way, there is no decision points whether I want to integrate that peak or not. That's a very simple approach is valid even when you have commemorating peaks, so there are some overlapping. Because if you note it for the GU value calculation, then the software will integrate it automatically. No need to manual setup, nothing. So it's a very repeatable way how to do the integration. And finally, I just show you some examples how precise it. Of course, the integration is done not by numerical integration, but we have fit modified Gaussian, which described pretty well the shape of the peaks. And that's the wall peak. You could see the top of the peak and the baseline. And you could see it's very tiny differences between the fitted and the actual trace, meaning that this integration approach is very, very accurate. So this is where we are right now. Again, we are doing the alpha testing right now, and I hope it's going to be public within 1-2 months, and then it's subjected for a broader audience to use. And finally, I just have to say thank you for my colleagues and also for your attention. Thank you very much.